Hello everyone. In previous class we studied about some numerical and third application. Today we will discuss some more numerical based on these applications. So let us start with one example, that is check the correctness of formula P is equals to 2 pi under root L by G, where T is time period of simple pendulum, L is the length of the string, and G is the acceleration due to gravity. Acceleration due to gravity. Clear? So a simple pendulum is a basic arrangement where this is the rigid base from which a bob is attached with a string, that is in fixed string. So in simple pendulum, move this bob over here and release it here. So what we will do is simply move back and forth motion. So from here to here, again here, this is called a time period. It starts from here, reach over here, and again back to this position. So the time taken by this bob to complete one oscillation is called the time period of simple pendulum. So we have to check the correctness of this formula. In LHS side, we can see LHS is T. T is time period, and we know that the dimensional formula for time period is capital T. Next, in RHS side, we have 2 pi under root L by G. And we know that this 2 pi is dimensionless constant. So remove it. Now what we have? We have only under root L by G. Under root L by G. Or this can be written as L by G whole to the power 1 by 2. Here, where L is the length and G is the acceleration due to gravity. So dimensional formula for length is capital L, and here we can put 1 by 2, and G is the acceleration due to gravity, or for acceleration we have dimensional formula Lt minus 2. Here, so Lt minus 2 whole to the power 1 by 2. So this becomes L 1 by 2. Here again over here it becomes L 1 by 2 and T minus 2 into 1 by 2. 2 cancel out, this becomes minus 1. So this will be equals to L to the power 1 by 2. Here we have again in the numerator side 1 by 2, move upward, this becomes minus 1 by 2. And for T is minus 1, move forward, this will become plus 1. So L minus half minus half, this becomes 0, L to the power 0, that becomes 1. So now we have only T. So in LHS side we have T, and in RHS side again we have a dimensional formula of T. So So according to the principle of homogeneity, both the terms in either inside have the same dimensional formula. So this formula is dimensionally correct. So here we can write according to principle of homogeneity, this formula is dimensionally correct. Here, next, next question. It is given that value of Stefan's constant sigma is equals to 5.67 into 10 to the power minus 8 joule per second per meter square per Kelvin 4. Here this K stands for Kelvin raised to the power minus 4. Here, find its value in CGS system. Here, so it is the this one is the first application where we have to convert one system of unit into another system of unit. So for that, what we generally used to do, simply we will find our dimensional formula using this equation or using this units. So dimensional formula for J, that is joule. We know that joule is the unit of work done, and for joule we have the dimensional formula of work done is mL2T minus 2. Dimensional formula of force is mLT minus 2 multiplied with length, that is mL2T minus 2 per second. Here, so for we know that the dimensional formula per second and this length, this is the Kelvin. So the dimensional formula for Kelvin is K. Question asked by Suryans. Here you can write the dimensional formula for Kelvin is K. Here, so in CGS system, it is taken as K, because in CGS system we have only three physical quantities, that is length, mass and time. Here, so for length we have centimeter, for mass we have gram, and for time we have again second. So that dimensional formula for this will become, for sigma, the dimensional formula is mL2T minus 2, and for second we have T minus 1 meter square. So L minus 2 and K minus 4. So K minus 4. So this can be written as m L to the, here it is 2, here it is minus 2. Here for t it is minus 2, minus 1, and for k it is minus 4. So m L minus 2 plus 2, 0. So t minus 3 and k minus 4. Clear? In SI system, value of n1 is equals to 5.67 into 10 to the power minus 8. m1 mass is written as 1 kilogram, or directly we can convert if we will not want to work hard. So directly we can convert, as we know that 1 joule can be written as 10 to the power 7 erg. We have already found it. So 1 joule can be written as 10 to the power 7 erg, where joule is SI unit and erg is CGS unit. Clear? So you can directly put it over here. No need to do that much of calculation. So in CGS unit, this can be written as this 5.67 into 10 to the power minus 8. This will remain. And for joule, we can write 10 to the power 7 erg. Clear? For second, it will become same. So second minus 1. Meter. 1 meter is equals to 100 centimeter. So 100 centimeter whole to the power minus 2, and Kelvin will remain as it is, so minus 4. This can be written as 5.67 into 10 to the power minus 8 into 10 to the power 7. Here this erg and second inverse, this is centimeter per centimeter square and per Kelvin whole 4. But this 100 to the power minus 4, minus 2. So 100 to the power minus 2. Clear? Or 5.67 into 10 to the power minus 8 into 10 to the power 7. This can be written as, this will be 10 to the power 2, and 2 multiplied with minus 2. So 10 to the power minus 4. Erg per second per centimeter square per Kelvin whole 4. Clear? So 5.67 into 8 plus 4 minus 12, minus 12 plus 7, that is minus 5. 10 to the power minus 5 erg per second per centimeter square per Kelvin whole to the power minus 4. So this is the value of sigma in CGS system. Clear? Next question. It is given that nu is equals to 1 upon 12 under root t upon m, where mu is the frequency of oscillation T is the tension in the string. Tension in the string M is the mass per unit length. Per unit length. M is the mass per unit length. Check whether the given equation is dimensionally correct or not. Clear? So we have a formula mu is equals to 1 upon 2L under root T by M. Here mu is the frequency. Clear? So in LHS side we have nu. Nu is the frequency, and we know that what is the frequency is number of oscillation per second, or nu can be written as 1 upon time period or 1 upon time. So dimensional formula for nu will be equals to T minus 1. Move this time upward, so this will become T minus 1. Clear? In RHS side we have 1 upon 2L under root T by M. Here, so 1 by 2 is again the constant term, so remove it. This is dimensionless constant. So what we have now, 1 by L under root T by M. Here, T is the tension in the string. Tension is a force. Tension is a force. Suppose if we hang anything from a rigid base through a thread, so the tension exerted in that string is known as the tension, and this is a force. So we know that the dimensional formula for force is mLT minus 2. Here, m is the mass per unit length. Here this m indicates mass upon length. So dimensional formula will become ml minus 1. Here, so just take care of this m, because it is given that m is mass per unit length. So mass upon length, so dimensional formula will become ml minus 1. Now 1 upon this L into T by M. Dimensional formula for T is mLT minus 2 whole to the power 1 by 2, because this can be written as 1 by L T by M whole to the power 1 by 2 because of under. So upon M, in place of M we can put ml minus 1 whole to the power 1 by 2. So this becomes L minus 1. Here M half 1 by 2, L 1 by 2, and T minus 2 into 1 by 2. Clear? And this M will move upward, become M minus 1 by 2. For L this becomes, here it is minus 1 by 2, if we move forward it becomes 1 by 2. Clear? So L minus 1. M half and minus half, so m raised to the power 0, cancel out. L half plus half, so L 1 and T minus 1. This becomes L minus 1 plus 1 and T minus 1, or minus 1 plus 1 0, L to the power 0, that is 1. So we have only T minus 1. So in LHS side we have T minus 1 and in RHS side again we have T minus 1. So we can say according to the principle of homogeneity, this formula is dimensionally correct. Clear? Okay. In next class, we will discuss some more fundamental based on these applications. Thank you.